Hello everyone, welcome to my video. I am Kshitija Wadverao from Sri Siddheshwar Women's College of Engineering, Solapur. Today I am excited to share my presentation on one of the topics of engineering physics, and I hope by the end of this video you'll see why. Let's dive right in. In this presentation I'll be discussing on GM counter. So let's get started. Geiger-Müller counter was invented by Hans Geiger and Walter Müller in 1928. The Geiger-Müller counter built upon Geiger's earlier 1908 alpha particle detector. This development marked a significant milestone in radiation physics. GM counter is used for detecting and measuring radiations like alpha particles, beta particles, and gamma rays. Here I'll be focusing on the detailed explanation of working, construction, curve or graph of GM counter, also the merits and demerits of GM counter. So let us see the construction of GM counter. GM counter consists of a hollow metal cylinder. This hollow metal cylinder acts as cathode. A fine tungsten wire is stretched along the axis of the tube. This fine tungsten wire acts as anode. The fine tungsten wire is connected to the positive terminal of the high tension battery through a resistance R, and the negative terminal is connected to the metal cylinder. At one end of the tube, a thin window of mica is arranged to allow the entry of radiation into the tube. Inside the metal tube, a noble gas is present, that is argon. Let us move forward on the working of GM counter. When a high energy charged particle enters through the mica window, it causes one or more argon atoms present inside the tube to ionize. After ionizing, the electrons and ions of argon causes other argon atoms to ionize. This process goes on, and the result of this one event is very sudden, and a massive electrical discharge causes a current pulse. The current through the resistance R produces a voltage pulse of order 10 microvolt. So this 10 microvolt is a very small pulse. So an electron pulse amplifier accepts the small pulse voltage and amplifies it to 5 to 50 volt. Then the amplified output is applied to the counter. As each incoming particle produces a pulse, the number of incoming particles can be counted. So, due to the high voltage between anode and cathode, an avalanche effect takes place. So, now you might wonder what is an avalanche effect. An avalanche is a process in which a number of free electrons in medium is subjected to strong acceleration by an electrical field, and it collide with other atoms in the medium and thereby ionize them. Here is the GM counter graph or curve. The x-axis represents the applied voltage and the y-axis represents the counting rate. As we can see in the GM counter curve, as we apply the voltage, the counting rate goes on increasing. At one point, it becomes constant and again increases. So, the constant region where the counting rate is constant, the difference between V2 and V1 is called as the plateau region. In GM counter, three terms are very important, and the three terms are given here. First is dead time. Dead time is the time period for which the counter is incapable of detecting any further nuclear particle. So dead time for GM counter is 200 to 400 microsecond. Next is the plateau region. As it's shown in the graph, the range of the applied voltage over which the counting rate remains constant is called as plateau. Next important term is quenching. When a free electron recombines with positive argon ion, it forms neutral argon ion. So this process leads to emission of photon, which also results in an unwanted pulse. So the method for suppressing the unwanted pulse generated by photon is called quenching. Now quenching in GM counter is achieved by adding ethanol because ethanol molecule absorbs the generated photons and suppress the unwanted pulse caused by it. So inside the metal tube, 90% of the metal tube is filled with argon atoms and 10% ethanol is present. Now we will move forward to see the advantages of GM counter or the applications of it. It is used to detect nuclear radiations and charged particles. It is also used to measure cosmic ray intensities. The counter setup is very light in weight and portable, and it is best for mineral prospecting. As we can see, there are many advantages of GM counter, but as well as it has some disadvantages, like it has a very large dead time which limits the counter rate, and it cannot detect natural particles like neutron. Also, it has a low efficiency for detecting gamma radiations. This was all about GM counter. Here we discussed the construction of GM counter, the working, the graph related to GM counter. Also, now we discussed the advantages and disadvantages of GM counter. Here it brings us to the end of my presentation. I really appreciate your attention and thank you for watching.